run through some answers. So shut your mouths. So sine 15. I'm going to use my, since we're in the summer difference section, I'm going to use my summer difference. So I'm going to use 45 minus 30. Sound good to you guys? Seems like the best one to use, so that's sine 45. Cosine 30 minus cosine 45 sine 30. What do I do next? Yeah, I go to my unit circle, and cosine or sine of 45 is square root 2 over 2. Cosine 30 is square root 3 over 2. Cosine 45 is square root 2 over 2. Sine 30 is 1/2. So I end up with square root 6 minus square root 2 over 4. Done. 2 is tan 15. Oh no. What? We did the odds. Good. That's one less thing for me to do. Mr. Cater, what can I help you with? Yes. You're welcome. Make sure you return her, though. Okay. Bye, Brooke. So 75 is 45 plus 30 sounds good to me. So I'll do sine 45 cosine 30 plus cosine 45 sine 30. Notice what's the difference between the one above and the one here? That's it, right? Everything else is identical. So guess what the answer is going to be? Yep. You guys happy with that? All right. Cosine of pi over 12. So this should be, pi over 3 minus pi over 4. Notice that you could have also converted it to 15 degrees and done it that way. That's okay, but good grief, guys, you should be able to do it using radians still. Yes. If it's adding, that doesn't matter. If it's subtracting, the one that's negative matters. And then we go to our unit circle. Cosine of pi over 3 is 1/2. Cosine of pi over 4 is root 2 over 2. Sine of pi over 2 is 3 pi over 2. And then 45 is that. So we have square root 2 plus square root 6 over 4. On 7. Tangent of 5 pi over 12. So this could be the same thing as 2/3, and 1/4. That sounds right to me. Wait a minute. Does it sound right to me? It's minus, right? No, that still doesn't sound right to me. You lied to me, Megan. Pi over 4 plus pi over 6. That seems right. Again, you could convert those into decimals and do it that way, right? Pi over 4 is 45. Pi over 6 is 30. 5 pi over 12 is 75. So that looks right. Applying my tangent formula. This is the nightmare, right? How many times did you have to do this on the test? At most once, right? So, fret not, kiddos. But this one is not nearly as bad. Why is it not as bad as the one we did before? Yeah, well, we also have these 1s in here. That makes life a little bit easier, right? And I'll multiply the top and bottom by square root 3. And then we'll multiply by the conjugate. So the bottom is 3 minus 1. The top is 9 plus 2 square root 3 plus 1, or 10 plus 2 root 3 over 2, or 5 plus root 3. Oh, 3 there? Sure. Root 9. There you go. Agreed. Thank you for paying attention. Everybody happy now? Okay. I'm like, I'm not sure which one you're talking about. Cosine 7 pi over 12. 7 pi over 12 I can rewrite as, yeah, so again, if you're not sure, this is 70, or 7 pi over 12 is 105, so we can think about this as like 60 plus 45. Oops, except it's the other way around. I would like you, if you need to do it like this, I'd like you to at least write it, like use the degrees to figure it out and then go back and write the radian on your paper. So like what I'm saying, Sophia, is you can do this and figure out 105 is 45 plus 60, and then look at your unit circle, and on your paper write pi over 4 plus pi over 3. You know what I'm saying? Like, for sure, think about it that way. That's the way I often will do it. But on your paper, write down the radian so it doesn't make it look like you can't add and subtract fractions in your head. You know what I'm saying? Yeah, okay. Cosine is cosine pi over 4, cosine pi over 3, and then minus sine pi over 4, sine pi over 3. Cosine pi over 4 is square root 2 over 2. Cosine of pi over 3 is square root 3 over 2. And then we have... oh, yes, thank you. Got going too fast. Ever happened to you? And there we go. I guess not. So, number 11. Yeah, I know, right? Isn't it wonderful? Well, they've all been like... Yeah, it's not uncommon to find like square root plus or minus square root 2 plus or minus 6 over 4. Just means you're working with multiples of 30, 60, and 45. It's like really common for that to happen. So for like number 11, what I'm going to do is I noticed that like the 45 is like our x and the 17 is like our y. So if I go to my formula sheet, I have sine x, cosine y, minus cosine x, sine y. That's the sine one, right? So this is sine of 42 minus 17, or sine of 25. And that's it. That's all I'm supposed to do. 13 is sine pi over 5. Cosine pi over 2 plus sine pi over 2 cosine pi over 5. So I notice again, this is like my x and y. So this is the sine one, but with addition. add those fractions, I need a common denominator, right? So 2 pi over 10 and 5 pi over 10, which gives me 7 pi over 10. Done. And then 15 is our last one. Tangent 19 plus tangent 47 over 1 minus tan 19 tan 47. So again, I'm going to think about these as like my x's and y's. This is the sum of tangents. Yes, you may. We all good in the hood here? We'll change colors just for grins here. Okay, so sine of 15. Here we're using the half angle identity, right? Is what it asks us to do. Okay. So that is sine of 30 over 2 plus or minus 1 minus cosine 30 over 2. Cosine 30, when I go to my sheet, is so what I'm going to do is multiply the top and bottom by 2 over 1. That gives me this, right? And then since the bottom's a perfect square, I can do that. And the last thing I need to do is decide on my plus or minus. Since we're sine in the first quadrant, that needs to be positive. Yes, Megan? Well, I square rooted the bottom. So this is what I did. Was the step in between there, Megan? Does that make sense? Good question. Again, if I skip a step, oh, yes. So remember, for sine and cosine, it's just like x's and y's, right? So 15 is here, so both sine and cosine are positive, and as a result, tangent's also positive because it's sine over cosine. If I'm in this quadrant, cosine, oops, yeah, sure. I like all silly turtles crawl because it's nonsense, but those silly turtles. All right. So if I do tan of 195, that is tan of 390 over 2. And if I apply the half angle identity, which one would I want to use? Does it matter to you? Okay. Okay, so how about the second one then? Because we had 3 options there. How do I do cosine of 390? That's the same thing as cosine of 30, right? Why is that the same? Because I go 360, and then 30 more is the same thing as just 30 degrees, right? What do we call those kinds of angles? They have a special name. Coterminal is the correct answer. Coterminal. I don't think they are isosceles angles. I'm not sure that makes a lot of sense. So we end up with 2 minus the square root of 3. What do you guys say? Okay to that? Cosine of 75 is cosine of 150 over 2. Oh, sure. So remember that tangent is sine over cosine, so it's y over x. So if you were in the fourth quadrant, you'd have negative over positive, which is negative. Correct. And if we chose the second identity there, because I have both sine and cosine in it separately, I end up getting, the sine works out automatically for me. As opposed to the first formula for it, where we have just cosines in it, then I have to be careful and think about what quadrant I'm really in. But if I have both a sine and a cosine in my formula, the quadrant is already decided for me. It accounts for it. Okay, plus or minus 1 plus cosine 150 over 2. I go to my UC. What's cosine of 150? Negative square root 3 over 2. And we'll clear that fraction out of there. And do I want the positive or negative here? I'm in quadrant 1, so I want the positive. Done with that one. These aren't so bad, right, guys? I mean, I'm ripping through them kind of quickly, but how do I write square root 5 pi over 12 as a half? $34, I thought. Yeah. So I rewrote it as the square root of the numerator over square root of the denominator. Right? You got to pay attention to where the square root is, right? The square root's including the denominator here, but not over here. So I just square rooted the denominator. Okay. Everybody good with how I rewrote 5 pi over 12 as 5 pi over 6 over 2? I'm sorry, what? Luck happens sometimes. So we have plus or minus 1 minus cosine 5 pi over 6 over 2. Ooh, be a little bit more careful there, Kulik. There we go. And cosine of 5 pi over 6 is negative square root 3 over 2. And we'll multiply by square root 2 over 1. And this, since we're doing sine of 5 pi over 6, what quadrant is that in? It's less than, it's in Q1. It's in Q1. 5 pi over 12, you have to look at the original. That's in the first quadrant, so it is positive. Okay, but here's the thing, is it asks you to use the half angle, not the angle sum and difference. Oh. Okay. So, remember that shortcut that you can just write it as like half the denominator over 2. It's easy to write those fractions as half angles, because that'll save you a little bit of doing there. So this can be 7 pi over 6 over 2. Which tan formula do you guys want to use? 1, 2, or 3? Sounds good to me. Then I go to my unit circle and set cosine of 7 pi over 6 is negative square root 3 over 2, and for sine it's negative a half. And then let's multiply both the top and bottom by 2 over 1. Sound good to you guys? Right, minus a negative half. Oh, what am I doing? Where's the 1 minus coming from? Ain't supposed to be there. Yeah, I don't know why you let me do that. That's better. And then is this our last one, 36? I know, right? We ripped through the entire homework assignment pretty darn quick there. It's like Mr. Kulik knew what he was doing or something today. Most days I don't, it seems like. And so we apply our cosine formula, plus or minus. 1 minus cosine pi over 4 over 2. Cosine of pi over 4 is root 2 over 2. Multiply by the square root of 2 over 1. Too big. And then what quadrant is pi over 8 in? Q1, so what is cosine? Positive. That's an assignment, what we just did right there. Boom daddy. That's right. Let's see, what do I want to do next? We're not going to take naps. What we're going to do is so what I want to do here is I want to talk about, stop talking please, solving trigonometric equations. So we should have done this already, but let's go back and look at some more of these. So, if I want to solve the equation 2 cosine x plus 1 equals 0, what I'm really going to do is just kind of think about the order of operations. But since I'm solving, I'm going to be running in reverse because I need to undo these things. So the first thing I should undo is any addition and subtraction. Do we see any addition and subtraction? Yeah, we have that plus 1. So to undo it, I'll subtract it. Okay, no more addition and subtraction to undo, right? Next thing we should do is undo any multiplication division. Do you see any of that? I do too. I see the 2. And now this E, when we did the order of operation, it stands for exponents. But really, it should stand for operation because like we do a square root at this spot, or we would do like a logarithm at this spot, or we do a trig function at this spot. So this is really operation. So we need to undo this cosine now. What operation cancels out a cosine? Cosine inverse. So cosine inverse of cosine x, those just cancel out and you're left with an x. So we have cosine inverse of negative 1. So how do I evaluate the cosine inverse of negative 1/2? I go find negative 1/2 on my unit circle. Which coordinate should I be looking for it at, though? The x or the y? The x. Why the x? Because we have a cosine, and the cosines are the x coordinates. So I see that at 2 pi over 3. Do you see it anywhere else? I also see it at 4 pi over 3. Now, these are our answers from 0 to 2 pi. But really, how many answers do I have? I have infinitely many. Because we have one answer here at 2 pi over 3. And we have another answer here at 4 pi over 3. And then we have another answer here at 2 pi plus 2 pi over 3. And then another answer here at 2 pi plus 4 pi over 3. And then another answer here at 4 pi plus 2 pi over 3, etc., etc., etc. Everybody kind of see this? I'm sorry, where are you at? Mm-hmm.
Well, in like the circle, if you go to negative 1 over 2, it's 7 pi over 6, and you could separate that.
That is the y coordinate, though. We're looking at cosines, so we want to look at the x coordinates.
So you could do that. Like that's what you're doing.
That's what we did to find the 2 pi over 3 and the 4 pi over 3. we did not use our calculator because the negative 1/2 is a unit circle value.
Okay.
We'll do one in a moment where we do need to use our calculator. Yeah. What do you need? Like, the inverse gets rid of the cosine. Remember, what sort of... Stop talking, please. When we take the cosine of something, what does that something need to be? It needs to be an angle. And what outputs from a cosine, sine, or tangent? A ratio of side lengths, a decimal number, right? So we input like degrees or radians, and we output like a real number. What the inverse function does is it maps the real number back to degrees or radians. So that's what's going on here. When I take the cosine inverse of negative 1/2, I get back an angle measure, either in degrees or radians. Okay, so back to this idea that we had infinitely many solutions really here, right? So how do I represent these infinitely many solutions? There's a notation to do this. So how often am I getting an answer that happens at 2 pi over 3? That happens every pi times around, or 2 pi times around, right? So if I start at 2 pi over 3, and I add to it any whole number multiple of 2 pi, I get another answer. So what is this saying? This is saying the answer is 2 pi over 3, and all the angles coterminal to it. That's just the notation that we write for it. How do we get an angle that's coterminal to 2 pi over 3? We add or subtract 2 pi. So that's what the 2 pi here is. This k, we're saying, is an integer. What are the integers? Positive or negative whole numbers. So if we add, we can go, if k is 2, we're going around twice from 2 pi. If k is negative 5, we're going 5 times around in the reverse direction and still ending up back there, right? So that's all that's saying. That means, okay, so this is the set of integers. What do we mean by the set of integers? We mean like the positive and negative whole numbers as well as 0. So because 3 appears in that, we say 3 is a member of the integers, or negative 3 is a member of the integers. Or we can say 2 is a member of the integers, but we would say 1/2 is not a member of the integers. So it just means that k is a member of that set. That's the notation that you would use. That's the standard notation you would see. So if you look in the back of the textbook, that's the way they're going to write it. So I wanted to make sure that I do that. So, again, if we have this, and you're told that your answer is between, we have. I just want to say there's a bunch of different ways we can ask this question. So if you're asked to solve and you're told that your answers are between 0 and 2 pi, you just have the two answers that we got. If you're asking to solve and you're told you want all the answers possible, we would write this one. You may be asked to do both of these kinds of questions in both the tests and the homework, and then we can do variations of this. What if I asked you to solve over this? So what I'm going to do is I'm going to use this part, and so for this one, k is -1, and for this one, k is 2. Because -1 times 2 pi is -2 pi, correct? Or 2 times 2 pi is 4 pi, right? So I can just use that answer and say that we have 2 pi over 3 plus 2 pi times -1. We have 2 pi over 3 plus 2 pi times 0. 2 pi over 3 plus 2 pi to the first. And then 2 pi over 3 plus 2 pi times 2. Oops. So how many answers do I really have here? I have 1, 2, 3, 4, 5, 6, 7, 8. Huh? Identities? No, those are all angle measures, right? So, for example, if you wanted to think about them as degrees, which is probably more natural for us. So this answer was 120. So if I go 360 less than that, I'm at -240. If I go 360 more, I'm at 480. If I go 360 beyond that, I'm at 840. So that's all we're saying here. 4 pi over 3 is 240. If I subtract 360 from that, I am 120. If I add 360 to that, I am 600. And if I add 360 to that, I'm 960. Notice that all these angles are coterminal, right? So it's basically the same thing as asking for all the answers between -360 and positive pi is 360, so times 4 is 1240. Okay. So I started with the answer that we got when we just solved it between 0 and 2 pi. And then I said, okay, I need to subtract 360 from it once, and then add 360 to it twice. So 120 minus 360 is 240, plus 360 is 480, and plus 360 twice is 840. it's the same thing. It's just radian answers versus degree answers. Right? So we're doing the same thing. Adding 360 and adding 2 pi, same thing, right? Gabby? The degrees for 4 pi, 1240. K is just the numbers inside the integers. So this piece right here is a notation saying that it's this answer and then all the angles coterminal to it. So all the angles coterminal to it are this. That's how we're notating that. How do we get an angle that's coterminal to 120? You're going to add or subtract a multiple of 360. So the 2 pi is your 360, and then k can be like any positive or negative whole number. So if it's negative 5, I've subtracted 360 from that 5 times, which will give me an answer. If k is 22, I've added 360 to it 22 times. The result is another answer. Is that all that's saying? Is k is a variable, but the only values it can have are the positive or negative whole numbers. Since it's being multiplied to 360, it's guaranteed to give you a coterminal angle, and since it's coterminal, it's guaranteed to be a solution because it's equivalent to 2 pi over 3. Does that help? Okay.
Under